A system is group of parts that work together as a whole. If we zoom out, the universe is the biggest system of all, and it contains all other systems. Earth is a system too. The Earth system is made up of four spheres or subsystems: the atmosphere, the hydrosphere, the biosphere, and the geosphere. For all of these Earth system to work, there is a requirement of constant energy. Energy is the ability to do work. So, where do we get this energy from? The Earth's energy are from two main sources. They are the sun and the Earth's interior. So, we saw that there are four different types of Earth spheres, yes? This would be the atmosphere, the living, anything living, the living animals, the birds would be the biosphere, and the layers of the earth would be the geosphere, and the water content in the earth would be the hydrosphere. Moving on to the next slide, let's see how the earth system involves the flow of matter and energy through different components. Let's take an example of water. The best would be the water cycle. Yes, in water cycle, what do we see? There's water evaporation from the ocean, and then it rises into the atmosphere, and eventually it falls back into the earth's surface as precipitation. So the rain and the meltwater then flows to the rivers, lakes, and the oceans, and eventually the water gets back into the river, and then it will go again back into the atmosphere. At each step of the cycle, at every step, energy is required to keep the cycle going. Evaporation of water requires heat energy. The heat energy may come from sun or from the earth as in a hot spring. Let's see another example wherein we use rocks as an example. Rocks also cycle through Earth's system. Hot molten material inside Earth called magma flows up through cracks in the Earth's crust. How does that crack occur? We saw in our previous videos that the crack occurs in the crust because of the plate tectonics, yes? So whenever there's a crack on the Earth's crust, the magma is gonna rise. This new material cools and loses heat energy to form a solid rock. Over time, the rock can be eroded into smaller pieces. If enough small pieces collect, they may get back together to form new rock, which gets pushed into the mantle, and again it becomes the molten magma. So what happens is solid rock is broken into pieces. Pieces harden into another type of rock. These rocks goes back into the magma and they melt and they emerge as new rock from the inside of the earth, and after they get emerged to the surface they cool and harden. So can you see each step, you see there is a requirement of energy, the heat energy. So what do we understand by the spheres? We see that all the four spheres must work in harmony to allow for the balance of life on earth. Any threat to even one sphere will have a drastic effect on the others. Next, let's see a little bit in detail about all the four spheres that we learned. Atmosphere. So starting with atmosphere, the atmosphere forms a barrier or bubble around the earth, as you can see here. And it is held there by the force of gravity. This keeps the vapors of the atmosphere from escaping into the outer space. So what happens if there is no atmosphere? The vapors that come are gonna escape into the space, yes? So that gets prevented by the atmosphere. Atmosphere creates a barrier between the earth and the harmful rays of the sun, thereby making the environment in the earth perfect for the animals, plants, and human lives to live. So you can see what's happening here. The sun's rays are coming down to the earth, but before they enter the earth, the atmosphere reflects back the harmful rays. Most of the harmful rays gets reflected back. Moving on to the next slide, let's see a little bit in detail about biosphere. So what's a biosphere? Is a sphere in which it includes all the organic living life, whether it's life on the earth's surface, in the atmosphere, or below the ground. In this way, the biosphere blends with other three systems of the earth. Can you see that in here in the picture? So there's some biosphere in the atmosphere, in the atmosphere, yes, and we can see biosphere even in the lithosphere, and also biosphere merges with the hydrosphere. Earth's life is much closer to the surface and can be found within about zero point 0.5 kilometers below sea level, zero point 0.5 kilometers below sea level, and 6 kilometers above the ocean's surface. There are 5 different kingdoms known as animals, plants, fungi, protists, which includes amoeba, paramecium, and monera, which includes the bacteria. And all of these encompasses the entirety of the biosphere. Next, moving on to lithosphere. What's a lithosphere? We have learned in detail about lithosphere in our previous videos, but let me explain. The lithosphere is the earth or the land portion of the earth. That's the topmost portion of the earth, basically the crust. It more specifically refers to the rocky outer surface of the earth's crust and the upper portion of the mantle. The earth itself is divided into several layers: the crust, the upper mantle, the main mantle, the outer core, and the inner core. Though all of this layer is the earth, only the solid upper portion are included in the lithosphere. This means it is generally solid as opposed to more liquid molten lower layers. So what does it mean is the molten liquid lower layers are not included in lithosphere. Lithosphere is more of the solid upper part of the earth. The lithosphere is the land on which the biological biosphere exists. Yes, biosphere like the plants and the animals. Yes. Moving on to the next slide. Hydrosphere. What's hydrosphere? By the word hydro, it means water. So the main first thing that should come in your mind when you hear hydrosphere is water cycle. The sun and the gravity is the driving force in the water cycle. How? The sun helps in heating up the water, which causes evaporation, and thereby there is condensation and then precipitation. That's where the gravity comes in action. Yes, the rain falls because of gravity. If there is no gravity, then the water droplets is gonna stay in the atmosphere. So because of the gravity, it comes to the earth, and then it gets collected, and then it's gonna run off to the in the rivers to the ocean, and the process repeats. What's sublimation? That's one new word we don't understand. Sublimation is something that gets converted from solid ice to vapor. It happens mostly on the glaciers. So let's do a small exercise in here. Match each sphere of the Earth's system with the corresponding features. Hydrosphere. Which could it be? Which could be the answer for hydrosphere? Hydro means water, yes? Glaciers. They are made up of water, yes? Lithosphere. What's lithosphere? The crust of the earth, the hard portion of the earth, yes? That would be the mountains. Atmosphere would be the oxygen. Biosphere. Answer would be the horse, all the living things, yes? Moving on to the next slide. Example of interaction of biosphere with atmosphere. All kinds of birds, yes. Example of interaction of biosphere with hydrosphere. All types of sea animals. Example of interaction of biosphere with lithosphere. Plants, animals, human beings, earthworms, and insects. Now let's see how these spheres interact with each other. In here we are seeing an example of interaction between hydro, that's water, and lithosphere, that's the Earth's crust. An event in one sphere can affect another, which in turn can affect another. For example, Greenland is losing about 250 billion tons of ice each year. As the massive ice sheet thins, the weight of the ice decreases. Here, if you can see, the massive ice sheets are thinning, and the weight of the ice has decreased. As a result, in some parts of Greenland, the land is rising above 1 centimeter per year. So, as this island, the green island, is losing the mass, losing ice, it's thinning, and the weight is getting reduced, because of which the land is rising. How does that happen? Let me explain. Here, also, if you see, there is that amount of rising happening. How does that happen? For example, a landmass that gets heavier by gaining more material will sink, while a landmass that gets lighter by losing material will rise. Like a boat in the water. with its cargo offloaded as shown here, it's gonna rise, yes? As containers are removed, there is less mass on this boat. This causes the boat to sit higher in the water because there is no buoyant. If you see, if there is more load in the boat, it sits a little lower in the water, yes? If there is less load in the boat, then the boat is going to sit a little higher. So it's the same concept in here. Since the weight, the load of this ice is low, it's going to sit higher. The sea level has risen at an average of 1.5 centimeters every decade for the last century. But during these last 25 years, the rate has doubled, mostly as a result of ice melting in Greenland and Antarctica. Can you tell me why are these glaciers melting? What's the cause? It's because of the greenhouse effect. Yes, we'll learn about greenhouse effect in our coming slides. So these higher sea levels threaten infrastructures such as roadways or utility lines. The higher sea levels are more vulnerable to Florida. So, because of the melting of these polar ice sheets and glaciers, you see that the level of the water is getting increased. And if you live near the coast of Florida, then you'd want to pay attention to what's happening to the Greenlands. About 82% of Greenland is covered by ice. In recent years, this ice has been melting at an advanced rate due to global warming. When ice on the land melts and runs into the ocean, it has the potential to raise sea levels around the earth. So because of the Greenland ice melting, you can see that there is increase in the sea level in the coastal areas. For example, let's consider that's Florida. You can see the sea level was here previously. Because of the glaciers melting, it has increased. Because of the sea level increasing, there is soil erosion. And later on, there will be destruction to the utility lines, roadways, all the other infrastructures in the city. Yes? So that's how it's of concern. Let's see another example wherein there's an interaction between lithosphere, biosphere, hydrosphere, and atmosphere. Basically, all the spheres getting involved. What could that be? An example of all the spheres getting involved would be a volcanic eruption. So, how all it affects? In the atmosphere, what it does is the volcanic ashes and gases that are coming outside reflects the incoming solar radiation and absorbs outgoing land radiation, leading to the cooling of the Earth's atmosphere. Biosphere. Formation of fertile soil helps the plant grow abundantly, thereby helping the animals and human beings. How does it affect the hydrosphere? Volcanic eruption causes water vapors. This undergo condensation, which becomes the Earth's water. So you understand now how volcanic eruption can affect the atmosphere, the biosphere, and the hydrosphere.